What do they say? They save the best to last, right? Okay, well, here we are. We have the best. Dobri, would you like to hold the microphone or would you like me to mount it in here?
I can hold it.
Yeah, there you go. Okay. Okay, hey, just hang on. It's going to go. Just let it take. Oh, there you go. Okay, very good. Just take your hand off. There you go. Yeah. Oh, I know what the problem is here. Would you hang on to this? I know what the problem is. See, again, we have a technical genius here at the stage, and he's going to fix the problem.
What's the problem?
It's not plugged in. 1, 2, 3, 4, 5, 6, 7, 8. Come on, you can do it. There you go. See?
Tonight.
Hold on, wait for it. Ta-da! Okay.
Thanks. Oh, thank you very much.
One point, again, please talk into here. And
Point
don't
to
get
here.
them too close. Yeah, there you go. Yeah, go ahead.
Put
Yeah,
it
put
in
it
my
in your pocket.
pocket.
Sure, yeah.
Very good. It's a pleasure and honor to be here. One thing is very clear from this conference is that we are wonderful in the longevity field and we can prolong people's lives, but we are horrible at keeping time.
No, I'm sorry. We're trying to extend time, and I'm doing a great job at extending the time of this conference. It's what we're here for. Come on. You're closer here.
Yeah, we're dealing with a lot of linguistic here, aging and timing and all that. So that's part of the deal, I guess. I think that the field of longevity has grown dramatically. To my astoundment, they have grown really, really fast. This is the 4th talk I've been invited to in the last month in 3 different continents. And that's only when I'm invited, which is not very often. It's blossoming tremendously. I agree with Carl about the nomenclature, but it is engraved now. There's no coming back. It's going to stay as longevity.
Hold it closer. Yeah, hold it there.
Even closer than that? Whoa. Wow. It's very good. There is one thing that changed our whole approach to aging and longevity, and this was, and this was the seminal paper of the convoys and their colleagues in 2005, I believe. This really changed the whole perception. People have been talking about aging and anti-aging and immortality for millennia. But until this point, it was all mythology. Maybe we talked about sharks that live 200 years, but nothing really scientific. And the explosion of the aging, the anti-aging, or the longevity field from a scientific point of view started right here. I'm not going to talk too much about this paper because it came from here. You probably know all about it. I'll just say that 2 mice, one old, one young, exchanged their blood circulation, and the observations were very serious, both pathologic as well as physiologic. But the bottom line was the old mouse became younger and the young mouse became older. The latter got discredited right away, and everybody said, well, something in young blood can happen. So there was a moment where everybody believed that something in the young blood was causing this change. And it went to a point that people making jokes of that, and it was, what we frequently forget is you're not a mouse. So at that time, I was working already with the convoys and their their fellows, and we had millions of discussions of what to do next, how to bring this from mouse to human. Is it possible? At that time, I was working with a group in Barcelona on the use of therapeutic plasma exchange in Alzheimer's disease. If there is any disease that is more associated with aging than Alzheimer's disease, let me know. So we organized a trial that is called the AMBER trial, and I was part of the organizing committee, and I thought that maybe we can use a similar approach, similar formula for the transition from the animal model to the human model, if you will. So in 2013, I believe, I published a hypothesis. We hadn't done anything yet, but I published a hypothesis, and I said, maybe therapeutic apheresis can be the parabiosis in humans. So for those who haven't heard my talks and don't know what therapeutic apheresis is, I'll play a short video.
Therapeutic plasma exchange, or TPE, refers to a specialized medical procedure in which blood separation technology is used to remove abnormal plasma constituents. Whole blood is removed from a patient into a blood cell separator, which utilizes centrifugal forces to separate whole blood.
Yeah, I'll lower it a little bit.
Therapeutic plasma exchange, or TPE, refers to a specialized medical procedure in which blood separation technology.
Oh, no, I got it.
I don't know.
I got it, yeah. Sorry.
No, this we have to get here.
Yeah, but where's the,
Slideshow from the beginning. We have to. I cannot get it. So.
where's your mouse?
Well, it has to be here.
Oh, there it is. Okay, so go over here to slideshow, say play.
I know.
Yeah.
Hold on. It's not doing it for some reason.
Okay, so let's just do this. Just a
From
second.
current slide? Just from current slide.
Mhm. I would just move on. Yeah.
No.
Yeah.
Hold
Yes,
on.
It's not going to go. You just have to move
No.
on the rest of the talk. Yeah.
No, it's not. Let's disconnect it and connect it again. It gives me the same thing.
Don't worry, but just move on the rest of your talk. Yeah, just move on to the rest of your talk. Just move on to the next one here. Yeah,
But
this stuff, and then
this
this
should
bundle.
not.
Yeah, sorry, it's not going to work. Go ahead. Yeah.
Well, I can't move the slides. I can't move the slides, though. It's not happening. I can't move the slides.
Let's see here.
Oh, let's load it again.
No. Let's just go share and from here. And, okay. I'm gonna get this thing going here. Okay, this thing. All right. The current one. I know that's the one. Well,
Let's load it
it's
again.
the application is stuck, so this is actually a Windows thing. That's why I'm a Mac
Let's
person.
load it.
So anyways, okay, let's slow that down.
Yeah.
Okay, don't say that. There we go.
Okay.
Okay, start up again. Can you help that, Dobri? Are you a Mac? I'm a Mac person, so yeah.
I'm one person support. Let's see. So did you exit?
Yeah, so it should be okay now.
Where is it?
Yeah.
And then just close this, exactly. We go to close this, okay. Then go to slide show. Just play from first slide. You want to play from this.
Here, yeah. See now if we
It will
can
not do it if you do not do
slideshow
slideshow. Exactly. It will only do it if you do slideshow.
from the beginning.
And you can do current slide.
Okay,
Uh-huh.
it should be good now.
All right. Team Browder Studio Computers, thank you so much.
Gotta live with that.
Therapeutic plasma exchange, or TPE, refers to a specialized medical procedure in which blood separation technology is used to remove abnormal plasma constituents. Whole blood is removed from the patient into a blood cell separator, which utilizes centrifugal forces to separate whole blood into its individual components: plasma, platelets, white blood cells, and red blood cells. Plasma can be removed and replaced with physiologic fluids to treat relatively uncommon but usually life-threatening diseases.
So you can figure out that we can dilute the blood, the whole blood, by removing large quantities of plasma, replacing it with other fluids. And obviously, the removal from this video is very simple. And the question was, what do we replace it with? And the immediate answer at the time was young blood. We will collect plasma from younger individuals, and we will replace the old plasma with the young blood. So at that time, I had been already 30 years in plasma apheresis, and I knew that this is really very dangerous proposition. We use fresh frozen plasma in people who are very sick and really need it, but the side effects are really dramatic. And despite my voice against the use of plasma, some people used it, and unfortunately we've witnessed few deaths from that approach, which is not a good idea. So usually we use 5% albumin as a replacement fluid in plasma apheresis in a variety of autoimmune diseases, and we've been using this for a long period of time without any serious side effects. And we decided to use this. So albumin is a very complex molecule, and it has a lot of different receptors, and it's used to transport hormones and other molecules around the body. So it's a transportation system of the body, but many of these receptors remain open, and free radicals join that receptor phenomenon as well. And therefore, albumin acts as an antioxidant, probably the most significant antioxidant in the body. It is also anti-inflammatory and has an immunomodulatory effect as well. Our first experiments were with a relatively small number of patients that we treated with plasma apheresis or therapeutic plasma exchange with albumin. And at that time, from the AMBER study, we knew that the protein composition of the plasma of younger people is very different from that of the older people. And now this is very well known, and there are papers left and right that describe that. But at that time, 20 some years ago, this was the first observation. Now, we were able, and actually the Convoys lab was able to replicate that. This is the picture from our study. On the left-hand side is plasma from older people. On the right-hand side is from younger people. As you can see, there is a considerable difference. And somewhere at the middle of the slide, we started doing plasma exchange. And if you move right, you'll see that the more plasma exchanges we did, the younger the proteome of the plasma became. We made all kinds of different observations, including the fact that we decreased inflammation. And as you know, inflammaging is a very important part of aging. We were able to alter the epigenetics of the participants. And we were also able to alter some of the genes, some of the DNA. I'll give you an example maybe of the target here, but recently the FDA approved the removal of LP A, which is a gene that affects 20% of the population on Earth and increases the risk of cardiovascular disease with 70%. So we removed the LP A with plasma exchange, and now there are pieces of equipment that are even more specific, that we specifically can remove this particular low-density lipoprotein. This is something that is very well publicized, and I'm showing it just to remind you that the process of aging is extremely complex, and we know some of it, but we certainly don't know all of it. So aiming at a single pill, this single drug that's going to affect all of that is unrealistic at the moment, and it will be unrealistic for a long period of time. At the same time, with plasmapheresis, we affect inflammaging, we affect the cellular senescence, the immunosenescence, and at the end of the day, we clean up the plasma from being not very clean and not presenting good environment to healthy milieu, which allows the stem cells and other cells in the body to flourish. So after our experiments with a smaller number of patients, I thought that it will be prudent to do a placebo-controlled clinical trial and see if what we saw in uncontrolled trial, we can replicate it. So it is a very complex work that's being done. We had divided 40 patients in 40 different groups. The shampheresis, or the placebo part, was very complicated, but our patients didn't complain much. In fact, there are two of our participants here in the audience. We can talk to them and see what their experience has been. I am very grateful to my nurses who performed outstandingly. It's very proud of the fact that we have only one relatively mild side effect in 360 procedures. We measured a variety of clinical parameters such as strength, balance, speed of walking, and all of those were significantly different in the placebo group and the real groups. We don't have time to talk about epigenetics here, but the epigenetic clocks are something that is being talked about a lot these days. When we started the trial, we started with 3 clocks. That's what was available. And we ended up with 35 at the end of 2 years. So this is the result of the 35 different clocks. If you look at the different colors, on the left-hand side is blue, and this means success with decrease of the biologic age. On the red side, these are the placebo group. They increased similar to their chronologic age. In a easier thing to read, this was given to me by Bobby Brook, who at that time was with the Harvard lab. And you can see here on the left-hand side is the decrease of the biologic age in the real group, all of them. And on the right-hand side is the increase of the biologic age, similar to what the chronologic age would have been in the placebo group. So these tests have improved dramatically over the years, and there is strong evidence now that even in younger people, if the biologic age is higher than the chronologic age, these people are more susceptible to develop diseases like cancer, cardiovascular disease, and so forth. And there are large studies from Europe as well as from China to do that. And this is one of the new tests by, what's the name of your company? Yeah, Generation Lab. And as you can see here, Generation Lab measures a variety of different systems, and they're adding new all the time. This is a patient before treatment, and this is a patient who after 6 treatments. You probably have seen this slide many times before, and it is clear now from our talks today or yesterday that age is the biggest risk factor for chronic inflammatory diseases, and it is of interest that people live longer because medicine has made tremendous strides and progress over the last 50 years. And now people don't really die at a younger age. They live longer, but they don't live a healthy life. They have problems and are on drugs and surgery. So if we are able to prolong the health span of people, at least with 2 years, and probably more, and have an intervention around 50 years of age that will prolong this health span, we can really make huge progress and save a lot of money to the healthcare industry. And I will end up this conversation here with a story that only a patient can deliver.
Feel great. I feel more energy. I feel muscle mass. I also just have a drive, absolute drive. I just feel very, very happy. And I also have a wonderful sex drive. And I'm 75.
Thank you very much.
Thank you so much. That was wonderful. And I forgot to mention something that's really important too for a longer life. And we talked about sleep, and we're going to ask questions, but I just want to mention about the last video you played is that we talked about sleep and we talked about good eating and exercise. But sex is really good too, right? It's a nice thing to do, right? And so definitely having more sex, I think, there you go, is a good thing. Okay, so questions for our speaker, please. Really? Okay. Okay. Well, you're up next, but he's a lot closer. Okay. I'll be back.
Excellent talk. Thank you. What is our sense about the duration of these, Dr. Kiprov? How long do we think we'll need to continue these or repeat these after the first treatment?
The schedule for the clinical trial involved 6 treatments over 6-month period, or 2 treatments in 1 week for 3 months. And all of those have a response. It is something that I forgot to mention because we didn't have time, but one of the groups had plasmapheresis, and after the procedure, they were given small dose of intravenous immunoglobulin, IVIG. And this group happened to do the best. They all did well. They all did very well. However, this one, statistically significant difference to the better.
When would you repeat?
When will you repeat is the question.
Yeah, at the moment, we don't have a clinical trial proven approach for that, but we recommend 3 to 4 treatments per year.
Okay, we have another question. All right, another question up there. Yeah. I think this will be our last question, and then we're going to say goodbye, but we're going to just say a few words. Thank everybody. But before we do that, obviously, we have one more question here.
Thank you very much, Dr. Kiprov. What age group shows the most response among the treated patients? What age group shows the most response among the treated patients? And if you could elaborate, what specific permissions do you require to make it a clinical practice? Thank you.
Yeah, so what age groups does the best in your trial? And what was the other question? You had another one. So what age group, sorry?
What permissions are needed?
Right, what permissions are needed? In other words, yeah. So is it just anybody can go to the clinic and get the perfusion, or is there something, paperwork or any issues regarding, I guess, yeah. There you go.
There are 2 answers to this. The first one is what happened during the clinical trial that we did, what I just described. In this trial, all patients were over the age of 50 with average age of 72. 72. So we excluded patients who had obvious chronic disease, cancer, type 2 diabetes, this kind of thing. There's maybe some milder abnormalities, and people that age have pains, and we accepted that. In real life, after the clinical trial, we treat a variety of diseases. And the most common ones are autoimmune diseases. And many of them do not fall into the category of well-defined autoimmune diseases, such as rheumatoid arthritis or lupus and so forth. So there is undetermined autoimmune response. And we see very good results in these patients. Another category that we treat is related to the fallout of the pandemic. And so we have chronic long COVID disease. We see quite a bit of those, and they can be either following COVID infection or in small number of patients, but significant disability is post-vaccine. We see that this has been described. There is an autoimmune disease that develops after treatment. So these are probably the most common diseases that we treat. We see another disease that is not very pleasant neither for the families nor for us as practitioners. It's called PANDAS, and it's It's immunologic brain disease. It's encephalopathy, usually in younger kids, but it occurs in older patients as well. And they have OCD, they have peculiar characteristics and all that. We see a lot of that as well.
All right, thanks so much. Yeah, thank you very much. Yeah. All right. Well, we've come to the end of the program, and like I said, we've extended it because that's what we're here for, extend things, life and conferences, right? So, but I think we've learned a lot, right? I hope it was worthwhile. I'm sorry? Yeah, we're gonna we can make it, Carl, anything you want. You got it. All right. So, but I would like to say thank you to a bunch of people here. Nuno Martins from Portugal, thank you so much for handling our technical things. David, our amazing AV guy, photographer, yay. Paul Spiegel for getting us on the nightly news. All right. Princess Haya, all the way from Saudi Arabia. Thank you. Melissa King. I mean, she's done way more than I can even imagine, and we're going to be here for another hour for me just to tell you all the things she did. Thank you. Shannon McEllier. Shannon, thank you very much. And thank you all for being here. And, oh, sorry. Michael Comboy at the very, very back. Oh, by the way, and okay, come here for a second. Come here. I don't want to screw this up again. Come here. Okay. I've been messing up her name all Irina Comboy, right? Thank you. Finally got it right. Irina Comboy.
Irene was very cute as well, so no worries.
Okay, but Irina Comboy and Michael Comboy, by the way, they provided the lunch on their own dime for everybody, and I thought it was amazing, right? So I'm going to find out what restaurants these were and go there, and because I'm going to go again. I thought the food was amazing, so thank you again. Again, they paid for it on their own dime. And again, thank you all for coming, and please talk to each other. What's that? And for next year, please come next year. We're going to have another one bigger, better, and everything, and so thank you again. Bye-bye. Thank you all. Thank you all. There's wine. Drink it. It's good for you. It'll make you live 100 years longer.